Hello, this lecture is going to cover sections 5.6 and 5.7. Starting off here with 5.6 with applications of rational equations and proportions. So just recalling here, chapter 5 dealt with rational equations. Now a rational equation or expression, let's say this is equal to, I don't know, some number like 21, right? This rational equation is defined with P and Q being polynomials, with Q not equal to 0. So just reviewing like the definition of a rational equation and what chapter 5 was talking about. Okay, so we've got another definition here. We've got the blank of A to B is A divided by B. What we're looking for here is the ratio of A to B. Furthermore, we've got an equation that equals two ratios or rates, right? A over B, that is a rate as well. This is called a proportion. All right, we've got a proportion here. A over B is equal to C over D. Given that B is not equal to 0 and in this case it should be D is not equal to 0, right? We don't want to divide by 0 here. So let's take a look at solving these types of proportion problems. Right, we've got t minus 1 divided by 7 is equal to 2 over 21. Okay, so looking here, we've got two fractions with two denominators, right? We've got 7 and 21. So there's a couple different ways we can do this. Let's see, can we multiply through, right, something over 1 to each one of these where our denominator will divide into that? And what we find is the least common denominator here is 21. So we can multiply through by 21 over 1, right? Means we'll multiply each one of these expressions by 21 over 1. So let's take a look at that, right? When we distribute, I'll show a little bit of work here. 21 over 1, 21 over 1. I don't know what that little arrow thing means. Hopefully it'll go away when I start writing. It did. We get, again, just filling everything in. T minus 1 over 7. Okay, so starting over here, we've got 2 times 21 over 21, right? So we have our common term of 21 over 21. So these divide out. We've got 2 on the right-hand side. Here, right, we've got t minus 1 times 21 over 7. Well, 7 will divide into 21 3 times. Right, so distributing the 3 here, we get 3t minus 3 equal to 2. So now we can solve this. Just for a little more space, let's go up here. Now we can add 3 on both sides. We get 5. So dividing by 3, we get that t is equal to 5/3. And so there is how we solve a proportion. Down here, we've got 3 halves is equal to v plus 5 over 5. So again, there's a couple different ways that we can do this here. Right? So one of the ways is multiplying, right? Again, you can multiply through by your least common denominator, which in this case would be 10. Right, so again, if you wanted to do it the exact same way as we did above, multiply through by 10, and that is how you would do that. But let's look at a different method. So same method as above, it's just a little bit different. So equal sign here, or a little arrow. Okay, so this is what we're starting with, right? 3 halves is equal to v plus 5 over 5. So we've got 10 and 5 as our denominator. So that means that 10 must be our least common denominator, right? Right? 10 is our LCD. Smallest number of both 5 and 2 divide into. So the question is there a number that we can multiply top and bottom here, numerator and denominator, that would give us 10 in the denominator? So hopefully you're seeing that all those different colors, hopefully you're seeing that we can multiply 5 over 5, right? Multiply 5 in the denominator, we get 10, which is what we want, right? And it's okay to multiply this side by 5 over 5 because it's 1. So we're not really multiplying, we're multiplying by 1 on this side. Over here, hopefully you see that it is 2 over 2, right? 5 and 2 give us 10. So we're wanting to get a common denominator of 10. Okay, so hopefully you can see, once you multiply that, you get 5 times 3, which is 15. Distribute the 2 to each one of these. Let's go ahead and write b plus 5 over 2. There's no need to skip all of the steps here. So once you distribute your numerator, you get 2v plus 10 divided by 10. So now we've got a common denominator of 10, which means that we can simply write this equation without that denominator of 10. Now you'd be asking, like, how do we go from here to here? Well, just think you could multiply through by 10 over 1, right? Multiply by 10, and then you have your cancellation here. And so that is how that is done, or why we can do that. Okay, so now we can solve this. We can subtract 10 here, 10 on that side. So we end with 5, or we have 5 equal to 2v. So v must be equal to 5 halves. You know it's good luck when we get 5/3 for the first one and 5 halves for the second one. So that finishes just the plain computation for section 5.6.